Hello guys, it's Isaac Frank. Welcome back to the advanced section of the Solidity tutorial series. In this section, we'll talk about the OOP aspect of the Solidity language. So this very video will talk about inheritance. So what are inheritance? Solidity Inheritance lets you combine multiple contracts into a single one. The base or the parent contracts are the ones in which other contracts inherit from. And the contract that inherits from the base are known as the derived or child contracts. This tutorial will discuss inheritance and the different types of it, which is the single and multi-level. Then also we'll review Solidity constructors. Lastly, we indicate some issues you face when inheriting contracts of the same name. Solidity inheritance is a process resulting in a parent-child relationship between contracts. There are two types of inheritance in Solidity, and they have the single and multi-level inheritance. So the single inheritance is, let's create some contracts here. Let me just duplicate this. So the single level inheritance is B. This is keyword is what we use to inherit from contracts. So we are saying B is A, which means we are saying B should inherit from A. So whatever functions and state variables and internal variables and internal functions from A will pass down to B. So when we do this, this is a single level inheritance because just one contract inheriting from a contract. I'll show you a visual representation of this. So this is basically what it does, and B is inheriting from A, which is a single level. So what about multi-level? Multi-level is when we are trying to nest this thing more. So we're saying something like A and contract C is B. So this is a multi-level contract because C is inheriting B and B is inheriting A. The visual representation should be something like this: C inheriting B while B inherits A. So C gets all the variables, all the functions, internal and public functions of B, and also get the internal and public function of A. So what this does, this first inheritance marks this into a single contract called B. So B is now equal to whatever A had. So C inheriting B simply means C is inheriting B and every of the A contracts. This is what a multi-level inheritance means. So in a contract, constructors are optional. So what are constructors? Constructor is an optional function declared with constructor keyword, which is executed upon the contract creation. So once we run the contract, the first time we deploy this constructor, apart from the state variables, which will be initialized, and the constructor is the first function, the block of code to run. So how do we declare a constructor? So in your contract, you have to make use of the constructor keyword, and then add your parentheses and give it a public type or an internal. Constructors can be public or internal. So give it a public type. And this. So right here we've declared a constructor for contract A, and if we should make this an internal scope, this makes this contract to be an abstract contract. In the next video, I guess we'll talk about abstract contracts. So how this works, the life cycle of a contract is, once we declare a state variable, let's make this public. Once we declare a state variable, it initializes the states variable which we have declared, and then goes to the constructor, runs the constructor code. After running the constructor code, it goes to the rest of the code, which are the functions. The longer the functions, the higher your cost, the gas cost is. If there is no constructor specified in the contract, Solidity by default adds an empty constructor, which is something like that will look like this. Solidity adds this to Solidity add this to the contract. So what's the use of constructor? Constructor are used to initialize a variable and maybe get it once you're deploying this contract, get an input from the user, then initialize this variable with the user's input, which brings us to arguments for constructors. Just like the functions in Solidity, constructors also take arguments. Let's make this public. If we should input an argument here, let's call this. And once the user passes the ID and this code runs, we initialize ID to equal whatever the user passes to us. So this is a constructor. As you can see, we now have an error here because it wants us to initialize the constructor, which we have not done. So how do we initialize a base constructor? To do that, we make use of the parentheses, and in this parentheses, we input the value we want to pass into this constructor, into the contract A. So this input 2, and then this is a way to initialize the constructor. But there are also two ways to initializing this constructor. So this is the first way, which we will just in here input this. But what if we are expecting the constructor from contract B, and whatever we get, maybe we want to square it and then pass to contract A? There's also another way to do this. To do that, we will not make use of this. So on the same line of the contract B constructor, we'll call the A contract, and we'll initialize the constructor here. So in here, if contract B is taking an argument also, in here, after it takes the argument, in here, we pass the argument to this, maybe square this by. So this also works. We've created a constructor, and the constructor takes an argument which points to this. So here we can initialize this constructor to be something else. So these are the two ways to initializing a constructor. First is this way, where we define it in the header. The second way is defining it in the constructor of the child contract. If a contract does not define the constructor of, as our constructor takes an argument, and this contract doesn't input the argument, doesn't define this, initialize this contract B, this contract turns to an abstract contract. We should mark this as an abstract contract. Just think of abstract contracts as contracts that do not define their function fully. So in the next video, we'll explain what an abstract contract is and what interfaces are and the difference between these two. So I'll change it back to be a normal code. Solidity also supports the multiple inheritance. There can be multiple levels of single inheritance. There can be multiple contracts that derive from the same base contract. So B can inherit A. Also C can also inherit A. As you can see, this also works, and this visualization will be something like A, this is a parent contract A, and A will go two ways, and this will be for B, and this will be for C. So these two are children of the A. A is a base contract, the parent contract that has two children, which is the B contract and the C contract. So this also works. There are some problems languages that accept multiple inheritance face, and Solidity is one of those languages that accept multiple inheritance. So just like Python, Solidity uses the C3 linearization. The C3 Just like Python, Solidity uses the C3 linearization to force specific order in which the base classes are given. You have to list the direct base contract in the order from the most based contract, most parent contract, to the most child contract. So for example, here would be, okay, we have contract A, we have contract B that is inheriting from contract A, and we have contract C. Let's say contract C wants to inherit from contract B and also contract A. And we should do something. Let me just remove this constructor. We don't need a constructor. Okay. Alright, so we are inheriting from, we want to inherit from contract B and then contract A. As you can see, we have an error, but just, there's no, looking at this code, you don't see any error here because we specified using commas you can inherit multiple contracts. So right here we've inherited from contract B and then contract A. But the error here is, let's see, linearization of inheritance graph impossible. So just like I said, it wants you to specify the order in the most parent contract down to the most derived contract. So here we're trying to inherit a child contract before inheriting a parent contract. So to specify this, to solve this error, we'll look at contract B. Contract B inherits A. So A is a parent contract of contract B. So A has to come first before contract B. So once we do this and clear this shit, once we do this, you see the error is gone. So if A inherited from another contract, they say A inherited from inheritance, and we try also inheriting from inheritance in here, we also get the same error, because this inheritance is a parent contract. It should not come last or before its child. So this inheritance has to come first, and as a parent contract, it has to come first. Oh shit. So once you do this, also you also solve the problem. So the way of inheriting has to be from the parent contract down to the most child contract. Next, we'll talk about is inheriting a contract that has members of the same name. So if, like right here, we have this contract has an ID. Let's make this ID public. This contract has an ID. Oh shit. This contract has an ID. What's happening? This contract has a state variable named ID. So what happens if here we also have a public named ID also? As you can see, this gives us an error because we are having a member variable that is exactly the same with our inherited variable. So it's just the same thing as doing something like this. And this also gives us an error because you can't have two variables of the same name in the same scope. What inheritance does is it copies this whole code and inserts it into this. So contract B will now be looking something like this, having duplicate variable with same name. So which makes this code not to run, which will give us an error. So when inheriting contracts, make sure your child contract doesn't have a name that will conflict with the parent contract. Also, this happens with functions. If your parent contract has a function with a specific name and your child contract also have the same function with that same name, and it also conflicts. Also happens with events. We'll talk about events later in this video. Also happens with events, and also happens with modifiers too. So this is one thing you should look at when inheriting from a contract. And right now we've talked about everything we have to talk about contract, but we never did a real life example. So for this case, I will create should I delete this? Okay, I'll create a contract. We'll call this math. This will be responsible for our mathematical functions. So we'll declare a function. It takes two parameters. Let's name this sum. Okay, it takes two parameter A and also takes B. It's public. Let's just make this internal since we are deriving from this contract. Internal means only a child class can call this function. So let's make this internal. If you don't understand what all these visibilities are, check my last video on functions where I explained visibility. So make this an internal function. What this does is return. I forgot to put my return statement here. What it does is returns a new int, and then here we just return a plus b. Also, we need another function, and this will be power. It raises a number to the power of the next number, so you should return this. So we've created two internal functions, and what else do we want to create? Okay, let's just use this for now and delete all this. And what? I don't need to declare you. So right now in this inheritance, we need to make use of the math contract. Okay, well, we need to make use of the math contract. If we try deploying this, let's say we have some logic in here, like a constructor that initializes this. See, the constructor that initializes name, okay, we have a constructor that initializes name, and I just use this line so that this code will be important. And we're trying to deploy this inheritance, this inheritance contract, but we also need to make use of the math functions. So if we go to the deploy tab and try deploying, you can see we only deploy per contract. We can't deploy 2 contracts at once. So this is why inheritance is useful, because right now if we deploy the inheritance contract, there is nothing useful here, just a name variable, a name state variable, and we need some functions and some things to do here. So to make use of that, so to make use of deploying just one contract and it having the other contract, we make use of inheritance. So right here we'll say inheritance is math. So in here right now we can create a function. Since we made this internal, we cannot see it outside, but let's just make this public. So in here right now, so by default, our contract have the pow, the raise pow function, and also have the sum function. So in here we can call it the sum, and we pass in variables to this. We can pass 12 and 9 or 8, size was 20, and let's put this in a function. So if we should deploy this inheritance contract, we should see this function and these other functions. Let's see. As you can see, we have the pow function, and we also have the sum function, but it wasn't declared in this inheritance contract per se. But because we inherited from this contract, what Solidity does is it copied the whole code here and just placed them into this place. So if we should call this sum, should return 20. Oh, we didn't return any value from here. Okay. So let's view, and should return 8. Okay, so if we should deploy this contract again, let me see, and we get the sum. If we should check in our transaction, we should see the output should be 20. Where's the output? Okay, yeah, as you can see, the output is 20. So this sum is available to us because we inherited from this contract. So this is the parent to this contract, and this contract is the child to this contract. So that's how inheritance works in Solidity. If you inherit from a contract, you get the state variables and the public and internal variables and functions alone. So if we should have a private variable here, this private variable, this private variable is only limited to the scope, to this particular scope. So we can't get this private variable from in here, no matter we inherited. So what inheritance does, it just gives us the public and internal variables of a contract. So that's all for this video on inheritance. In the next video, we'll talk about abstract contracts and interfaces, because abstract contract is more like an interface, but there are some difference in it. That's it for this particular video. I'll see you guys in the next video. Bye for now.